Welcome back! Now that we have our social network loaded in BeGraph, we are going to find the right visual representation of it. In this video, we will comment briefly on the 4 different available spatial layouts, apply one of them, and see how our network expands and reveals its structure. First, we load our network. Remember, we named the workspace My First Network. And the network is Social Network. Click on Go to Layouts or on the Layouts tab to enter the menu. The first 3 layouts, specifically Force Atlas, Fruchterman-Reingold, and Kamada-Kawai algorithms, are force systems based on physical models. These algorithms tend to repel every pair of nodes and attract nodes that are linked. In this way, the topology and structure of our network is mapped into the 3D Euclidean space. The Force Atlas layout is the most efficient algorithm in BeGraph, but it is kind of difficult to manage because it has many input parameters. You will need some expertise and trial and error tests to find an interesting layout. On the other hand, it is very fast and works well on large networks. For smaller networks, we have the Fruchterman-Reingold algorithm, which has few input parameters and can produce beautiful and meaningful results. Finally, the Kamada-Kawai algorithm can also produce very good layouts, but is the most computationally expensive, and we do not recommend using this for networks with more than a few thousand nodes. Apart from the force-directed layouts, you can also do a usual scatter plot in 3D or 2D according to some node properties, ignoring any network structure. We recommend checking out the BeGraph user guide for more information. Now we will apply the Fruchterman-Reingold layout to our social network. We will try with the default parameters and see how it goes. The initial state is a sphere. Immediately the nodes start moving. Clicking on this icon, we can see the links while the nodes are moving. The full network expansion takes approximately 1 minute. Let's watch it for a bit. Meanwhile, it is important to notice that the main advantage of the Fruchterman-Reingold layout is that it usually works fine and smoothly with its default configuration. We definitely recommend it for starters, but remember, don't use it for big networks. Now we see how the network is divided into groups of highly connected nodes. In the network science terminology, those groups are called communities. It is also clear now which nodes are connections between communities, like this one and this one. Finally, we get the job finished message from the cloud. That's all for this video. Please continue with the tutorial to learn how to run network metrics and create professional visualizations of your data. Thanks for watching.